Example 3. This is a triangular brace, so perhaps this is made of wood or perhaps some kind of metal. It says the angle opposite the 9-meter side measures 70 degrees. Okay, so basically that entire thing is 70 degrees. What is the height of the brace? There's a couple reasons I like this problem, because it does address possible errors that you may make in other problems. Any suggestions on helping me find basically h? Yes? Oh. Okay, so you're saying kind of forget about the 70 for a little bit and go ahead and just find where I put the red dot. Okay, and what do you come up with? We've got 31, 90, and okay, so 59. And if we know the whole thing's 70, well, that's obviously 90. If we know this whole thing up here is 70, how much is left over for that other side? 11. And while we're at it, we might as well find that one where I just put the red dot. 2 ways you could do that. What is it? 79. Okay. Well, we got all our angles, so we're off to a really good start. Unfortunately, how does that help? Oh, it does. Yeah, the 9 I put in a very specific spot to have it cause problems. The reason you're struggling on this one is you want to be able to solve for h right away. You can't. You got to go solve something else first. And it doesn't even matter. You can solve this side over here first. We'll call it x. Or you can go solve that side first. We'll call it y. Really doesn't matter. But once you solve for that one, you can actually go ahead and solve for h. Because right now we only really have one pair, and that's in the bigger triangle. And this is really bad, but anyway. Yeah, I can't even handle that. It's so bad. We've got 9 meters. We've got 70 degrees here, 79 degrees there, and 31 there. All I've done is taken the middle one out. Do we have a pair? Yes, we do. And the problem is once you take that out, I can either solve for this, which I've called y in that other picture, or that, which I've called x. Correct? That's really all you can do if you're going law of sines on this. Okay. And so does it matter? No. So you just basically have to pick one. I heard x, so let's go for that one. So it's sine of 70 degrees over 9. And then if we're going for x, that would obviously be on the bottom. What goes on top then? Yep, sine of 31 degrees. So why don't you go ahead and solve for x right now on your own. I think you're all capable of doing that. And we'll round to the 10th. I think that's fine. It'll throw things off a little bit, but not too bad. I have heard for x 4.9. Do we agree with 4.9? Does it make sense in the picture? Yeah, it does. So is x what they're looking for, though? No. Now that I have that, everybody take a look up here. If you haven't figured it out yet, we can take this triangle. This is 4.9. That's 90. That's h. 79 degrees, 11 degrees. Here's the part that some people don't realize. Do we actually have a pair in that green triangle? Yeah. Remember, in SOHCAHTOA and Pythagorean theorem, I said, in SOHCAHTOA especially, I said stay away from the right angle. Did I say that for law of sines? I never said that for law of sines, did I? So you got a pair. Go ahead, use it. And in fact, most people at this point forego SOHCAHTOA, and they just say, I'm just going to use law of sines. And that's fine. Now that you've shown me you can do that. So it's sine of 90 degrees, of course, over 4.9. Because was there any way of me avoiding the rounding this time? Not really, unless we went exact with that big long decimal. And then if I'm going to find h, what is going to be on top of that ratio? Sine of what? Sine of 79. Go ahead and tell that. Are we expecting it to be very far from 4.9? Less or more? Less. H is going to be less than 4.9. It has to be because 4.9 is the hypotenuse of the green triangle. Anybody feel they have H? 4.8 what? Meters. So, the one thing I want to show you with this example, and one of the reasons I like it, is now you know law signs will work for right triangles, as long as you have a pair. Another thing that I'd like to point out is some people, when they set up this one right here, some people think setting up that right there will actually give them the height. Here's why. They see, hey, this is 70 over 9, 31 over H. Perfect. Law of signs only works if you're talking about one triangle. If you do that, you're talking about the big triangle, and then you're talking about trying to talk about that little triangle, and that's not going to work out for you. Where if you just look at the big one, yes, 70 and 9, 31 and all the way across works. Okay? And then you can work your way back through the problem. Okay? So keep that in mind. Law of signs only works if you're talking about one specific triangle, not multiple ones inside of each other. Okay? Any questions?